Metabolic integration, caloric intake, biochemistry. Variable fuel input. The variable fuel input, they are storage fuel, they use oxygen, they produce ATP, it has a cycle and variable metabolic demand. The final result is carbon dioxide, water and urea. This is a human can use a variable fuel input to meet a variable metabolic demand. Brain, pancreas, lymphatic vessel, everybody is involved in the fuel production and fuel usage. Well-fed state. On the well-fed state, when we feed a lot, we are not hungry, we have a satiety. We have a satiety. The gut has a glucose amino acid is come to the portal vein. The pancreas secrete the insulin. The glucose enter to the liver, or the amino acid enter to the liver. From the amino acid we have a protein. From the amino acid we have a pyruvate, the glucose, and the final product is carbon dioxide, water, and urea. Okay. On early fasting state, when we are hungry, the glycogen produce glucose, the glucose produce lactate, and the lactate alanine has a recycling on the blood and all of the body. On the fasting state, when we don't eat anything, not the early, when we are completely fasting, protein also break down to the glucose, alanine, and glycerol also produce energy. Okay, not just the glycogen, the protein and glycerol also income. The hormone glucagon from the pancreas and epinephrine from the renal medulla, and iodothyronine level decrease, reduce the basal energy requirement. Glutaminolysis. The glutamine from blood enter to erythrocyte. On the erythrocyte, from glutamate produced, and the ammonia release, and the ammonia is go to the urea cycle. The glutamate come to the pathway, and the glutamate plus pyruvate, the alanine release, and the alpha ketoglutarate produced. The alpha ketoglutarate again back to the erythrocyte by the citric acid cycle to produce more and more and more energy. Okay. On the lymphocyte, the glutamine comes. The glutamine again produce glutamate. Here, the glutamate by oxaloacetate produce aspartate and alpha ketoglutarate. On the erythrocyte, pyruvate alpha ketoglutarate. On the lymphocyte, oxaloacetate alpha ketoglutarate, not the pyruvate. Here, the aspartate produce. Here, the alpha ketoglutarate beside on the cytosol is produced. Glutamine catabolism by rapidly dividing cell. By rapidly dividing cell, glutamine aspartate required for synthesis of purine and pyrimidine. The rapidly dividing cell needs glutamine and aspartic acid for the synthesis of purine. Do you remember the aspartic acid? Aspartate with carbamyl produce purine. Plasma level and days of starvation. On the second day of starvation, just the fatty acid is very low, and the glucose is very high. But after 4 days, 6 days, and 8 days of the starvation, the ketone body plasma level increase a lot, glucose decrease, and fatty acid is also increase. The free fatty acid on the blood increase. Days of starvation, the beta hydroxybutyrate increase, the glucose level decrease, free fatty acid increase, acetone increase, and acetoacetate also increase. But beta hydroxybutyrate a lot. Beta hydroxybutyrate is one of the ketone body. Acetone is one of the ketone body. Acetoacetate is one of the ketone body. It means between these three ketone body, beta hydroxybutyrate is increased more than acetoacetate, more than acetone. Fuel metabolism in starvation. Fuel used by the brain. Which fuel is used by the brain? Glucose, ketone body, and all other use of glucose. Fuel mobilization. Adipose tissue lipolysis, muscle protein degradation. From muscle protein degradation and from adipose tissue lipolysis. Fuel output of the liver. Glucose and ketone body. The fuel output of liver is glucose and ketone body. If we are on starvation, it means we get the fat from adipose tissue and we get the protein from muscle. لاغر میشه. Metabolic interrelationship of major tissue in the early refed state. Fat is metabolized normally, but normal glucose metabolism is slowly re-established. وقتی که تازه غذا خوردیم fat is metabolized normally but normal glucose metabolism is slowly re-established. سخت برمیگرده. slowly re-established. Energy requirement reverse and caloric homeostasis. An average person consume 180 to 280 gram of carbohydrate, 70 to 100 gram of protein, and 70 to 100 gram of fat daily. This means of the daily energy requirement of 1600 to 2400 kilocalorie. The daily energy requirement is 1600 to 2400 kilocalorie. Fuel reverse in typical 70 kilogram man. Available energy in kilojoule. Organ is blood, liver, brain, muscle, and adipose tissue. Needs 250, 1730, 5000, and 330. Who needs more? Muscle. After the muscle, liver. After the liver, adipose tissue, and after the adipose tissue, blood. Available energy. Triacylglycerol is much more in adipose tissue. Mobilized protein is much more in muscle. The available energy. Available metabolic fuel in normal weight 70 kilogram man, and in obese مرد خیلی چاق 140 kilogram man at the beginning of fast. Normal weight تریاسیلگلیسرولش 15 پروتئینش 16 گلیکوژن 0.23 و circulating fuel glucose 0.023. In the obese triacylglycerol is 80 instead of 50. Triacylglycerol is a lot, 80, but the other is absolutely same, nearly the same. Just the triacylglycerol adipose tissue is a lot in the obese. Calorie homeostasis, the constant availability of fuel in the blood. In the well-fed, high insulin-glucagon ratio, glycogen and fat storage. In the starving, low insulin-glucagon ratio. اگر low باشه یعنی اینسولین کمه گلوکاگون زیاده. وقتی های یعنی اینسولین زیاده گلوکاگون کمه چون یک کسر دیگه. وقتی که تو استاروینگ هستیم لیپولایزیس، پروتئولایزیس، گلوکونئوژنزیس را میافته. ولی وقتی تو حالت ولفت هستیم سیرین گلایکوژن و فت استوریج تولید میشه. افکت how blood glucose in human. افکت بلاد گلوکوز چیه؟ رنج نرمالش بین 60 تا 90 که اگه بیشتر از 110 میشد دیابتیس. بین 60 تا 40 استیبل نورولوژیکال ساین هانگر ریلیز اف گلوکاگون. بین 30 تا 40 لتارژیک کانفوژن کما و توی 10 پرمننت برین دمیج. If prolonged death happens. تموش.